All right, so today we have to, we'll first go over the basic concept of oxidation of alcohols. And then once we're done with that, we will move on to past paper question for that. Also, there's the iodoform reaction. So we have to touch upon both of those. So let's start with oxidation. Now, alcohols, when they oxidize, there is two considerations that you have to remember. Whenever alcohols oxidize, so what's the alcohol? There's OH, and this carbon can have H. Now, let's say this is a tertiary carbon, which means that if I were to oxidize it, तो मुझे क्या करना चाहिए? मुझे oxidizing agent चाहिए. So there are four oxidizing agents that we should know about. One is a strong oxidizing agent. एक हमें उनका पता होना चाहिए. और दूसरा weak oxidizing agents. हमें उनका पता होना चाहिए. So there's two of each category. The strong oxidizing agents that we know of, one of them is KMnO4, potassium manganate 7. We always use it in H positive, which means that we use it in acidic media. Now, whenever this reacts, it goes purple to colorless. So that's the strong oxidizing agent, KMnO4. Now, how does it do that? It absorbs or it takes 5 electrons. So it's a very strong oxidizing agent because it goes from +7 to +2, and that takes 5 electrons from whatever it is oxidizing, obviously. Okay. Now, the second strong oxidizing agent that we have, that is K2Cr2O7. And again, we use this in the presence of H positive. Again, acidic media. The color changes orange to green. And how it happens is that chromium 6 plus changes to chromium 3 plus. Okay. And that is how it absorbs, or it takes 3 electrons and it is able to do that. Now, there are two other weak oxidizing agents that we should know about. One of them is called Tollens reagent, and the other is Felling's solution. Okay. Now, does not mean कि यही oxidizing agents हैं. There are many other oxidizing agents. There is Collins reagents. There is a PDC एक चीज होती है. There's Day-smarted periodine, इस तरह करके एक अजीब सा नाम है. वो भी होता है. So there's many oxidizing agents that we use. But these are the four that we should know about whenever we are reacting. Now, how does Tollens reagent work? Tollens reagent को हम silver mirror भी बोलते हैं. And what it does is that silver mirror, it has silver ions in it, ठीक है? और वो silver ions जो हैं, उनका कोई color नहीं होता, and they change to silver metal. Okay, so that means silver ions which are colorless in the solution, they change to silver metal, and that is what we get. Now, Felling's solution, on the other hand, has copper ions in it. So Felling's solution has copper 1 ion, copper 2 plus ion, they change to copper plus 1, तो एक इलेक्ट्रॉन्स लेता है. और इससे हमारे पास बनते हैं copper 2 is blue, which changes to red brick solution, या खाली red भी आप कह सकते हो. ठीक है. So we have these strong and weak oxidizing agents that we have, और इनको यूज करके हम ऑक्सीडाइज कर देते हैं अल्कोहल को. Now, it is often said that the weak oxidizing agents will not oxidize alcohols. Now, that's not always the case, because if you heat it, then they will. Okay, so if you're using weak oxidizing agents, you just need to make sure that you're heating it. And strong oxidizing agents can oxidize even at room temperature. Especially primary alcohols, तो वो oxidize कर लेते हैं. अब ये primary alcohol क्या चीज़ है? So alcohol can be attached to 2 carbons, the carbon that's attached to, let's say, and एक hydrogen हो, और ये भी हो सकता है कि उसके साथ सिर्फ एक carbon attach हो और बाकी दोनों hydrogen हो. Now, this one is called a tertiary alcohol, secondary alcohol, primary alcohol. Okay, so tertiary, secondary, primary. Now, whenever you oxidize them, you have to remember that we will remove 2 hydrogens to oxidize anything. Can I remove 2 hydrogens from this carbon or next to this carbon? I can't, because while there is this hydrogen, कोई और हाइड्रोजन इस कार्बन के साथ नहीं है. हाँ, इस कार्बन के साथ, इसके साथ हो सकती है. We don't know, but इसके साथ कोई हाइड्रोजन नहीं. So this does not oxidize because you can't remove 2 hydrogens. This one I can oxidize.
Sir,
Yeah.
I'm so sorry. Could you repeat for like the tertiary one?
So the basic idea of oxidation in this case is that you're removing 2 hydrogens. I can't remove 2 hydrogens next to this carbon. हाँ, मैं इस OH में से H निकाल लूंगा, but the other hydrogen I don't have any. So that means I cannot oxidize it. So this means you can check whether an alcohol is tertiary, secondary or primary. अगर आपको पता है ना कि ये चीज alcohol है, तो you add a strong oxidizing agent in it. If it does not change color, but you're certain that this is alcohol, इसका मतलब है वो tertiary alcohol है. Now, these 2 hydrogens I can remove. And when I remove them, this hydrogen goes away, this bond goes away. So now carbon and oxygen, they have just one bond that they need to make. So वो इन दोनों की bond टूटती हैं and they make a new bond here. That is how they oxidize this. So when I oxidize this is the symbol for oxidation. And I will be removing 2 hydrogen to make water. और जो बाकी बचेगा ना, मतलब ये भी खत्म हो गया, ये भी खत्म हो गया. So जो बाकी बचा है, they are going to make 2 bonds together and you get this thing which is called a ketone. Ketone is basically a secondary carbon next to an oxygen. Okay? So this is a ketone group. Now then I have primary alcohol. Primary alcohol जो है ना, I have more than 2 hydrogens that are available to me. So that means I can oxidize it and then I can further oxidize the product as well. So सबसे पहले तो जैसे ketone में मैंने ये दोनों hydrogen remove किए थे, I will remove the same here and I will get, so I will add the oxidizing agent and I will get, वो दोनों remove हो गए हैं. So इधर carbon था, इधर hydrogen था और अब यहाँ पर double bond create हो जाएगी. And this part is called aldehyde. And we write it as CHO group. Obviously इस side पे R है और बाकी side पे CHO है. इसमें क्या है? RCOR. मतलब ये कुछ भी हो सकता है. So basically the R is the carbon chain that's attached. वो कुछ भी हो सकती है. With the carbonyl group and then the other alkyl group. Here I have R with carbon and that carbon is attached to hydrogen and it's also attached to oxygen. Okay. So we get this thing here. Now, this will make that, and of course, water is made as a byproduct. अच्छा, अब ये aldehyde जो है ना, you need to remove it right away. If you don't remove, what happens? Because aldehyde also has hydrogen in it, and if I have oxidizing agent in excess, वो वहाँ पे अभी भी available है. This oxidizing agent, which is available, can remove this hydrogen as well. And so what happens is कि पहले ये दोनों तो oxidize हो गए, but this one will also be oxidized and now this thing will create carboxylic acid. So the H, through a bunch of reaction that we don't need to get into the detail of right now, कि कैसे ये OH बनता है, we don't need to get into that. Just know that this hydrogen will now be converted to OH in presence of water and presence of oxidizing agent. In fact, aldehydes are so good at oxidizing that any oxidizing agent will work. Strong, weak doesn't matter. Similarly, this one as well, strong, weak doesn't really matter, but weak के लिए हमें बस oxidize करते हुए heat करना होगा. Strong room temperature पे भी कर सकते हैं reaction. So here's the thing. If you don't remove this thing, then the moment it is made, it will oxidize to carboxylic acid.
Sir,
So yeah,
where did the H come from? Carboxylic में?
I'm sorry.
Like वो जो O के साथ H है, I don't get where
Hmm.
that came from. क्योंकि अगर हमने वो second carbon like remove like hydrogen remove किया, right? तो I get that part, but like oxygen के साथ H कहाँ से है?
Oxidizing agent की वजह से you have oxidizing agent available, and that is reacting with the aldehyde.
Makes sense. ठीक है, thank you.
Yeah. And now you can get directly to this. If you don't want to go through the aldehyde route, basically होगा वही, लेकिन होता क्या है कि हम उसको बोलते हैं reflux. The idea of reflux is that you are not letting the product escape. Aldehyde बने, आप उसको वहीं पे रखा हुआ है आपने. And I also have oxidizing agent there, which means that now this aldehyde can collide with the oxidizing agent. And when they do that, I will be able to get carboxylic acid, because the moment aldehyde is oxidized, I get carboxylic acid. Okay. So if you do reflux, you don't let any aldehyde formed escape. और जब वो escape नहीं होगा तो there is likelihood कि वो collide करेगा oxidizing agent से. और जब वो उससे collide करेगा तो आपको वो product में मिल जाएगा. Make sense?
That's it.
Yeah.
What was the reason that tertiary ones don't get oxidized?
So tertiary ones do not have two hydrogens that I need to remove. And because oxidizing agent has to make water by getting two hydrogens, so वो water बना नहीं सकेगा.
So hydrogen उसी कार्बन पे होना चाहिए दूसरा वाला जिसके साथ OH लगा हुआ है.
जिसके साथ OH होगा. उसकी reason के why does that hydrogen get removed has a lot to do with the polarity of the bond between carbon and oxygen.
Okay, sir.
Yeah. क्योंकि कार्बन हाइड्रोजन बॉन्ड एक तो बहुत स्ट्रांग होती है और सेकेंडली वो नॉन पोलर होती है, तो उसके लिए हाइड्रोजन का रिमूव होना मुश्किल है. But the moment you introduce O there, because of its strong electronegativity, वो उस बॉन्ड को भी डिस्टर्ब कर देता है, कार्बन पे डाइपोल्स क्रिएट करता है, जिसकी वजह से उस हाइड्रोजन को रिमूव करना आसान हो जाता है. बट
Alright.
ये सारी डिटेल वो आपसे पूछता नहीं है. ना ओवर हियर अगर मुझे सिर्फ एल्डिहाइड चाहिए, I don't want it to oxidize, then I need to make sure the moment aldehyde is made, I am able to get it out. Okay. And how do I get it out?
Distill.
Distill, exactly. The moment it is made, I make sure कि उसको मैं बाहर निकाल लूं. And to do that, I will need to do what is called distillation. So if I distill it, then I will get that separated, and that will be there. मुझे आराम से मिल जाएगा. But if I don't get it, तो फिर मुझे वो नहीं मिलेगा. All right. So let me show you what this looks like. So if you look over here, this diagram, this shows the two processes. Now this is from notes. Sir Bilal Hamid ke notes hai ye. So what's happening here is that water in here is coming in, and so what is coming in here, it is going out here by going around it. This is called water jacket, या condenser. Now, when you heat it, it escapes but gets cooled down and comes back. So this is called reflux. It is used to make sure that if you're heating something volatile, every time you have something volatile like alcohol and you're heating it, you need to make sure that there's not a buildup of pressure. But at the same time, you don't want the vapors to escape. तो इसकी वजह से क्या होगा कि हम उसको साथ साथ वेपर्स को कूल करके वापस फेंकते रहेंगे. So that is how you completely oxidize it. You convert it to aldehyde, but उसको आप escape नहीं होने दे रहे, तो वो वापस carboxylic में convert होएगा. But over here, the moment it is made, I collect it here, and I'm able to get it. This is something that we're familiar with from O levels. So if I say distillation separate apparatus is nothing new for us. Okay, and that way we are able to get this. So the idea is that you can oxidize alcohol as long as you have two hydrogens available. And if you have more than two, then you can further oxidize it, and that will give you carboxylic acid. And of course, you can't further oxidize carboxylic acid because now you don't have two hydrogens available. तो इसको आप further oxidize नहीं कर सकते हो. Same ideas. अच्छा, तो ये हो गया हमारे पास oxidation. अब अगला step ये कि let's do a couple of examples. Let's say I have, okay, so this is an interesting one. I oxidize this. What will I get? For that, I have to identify every carbon. Let's start with this carbon. Primary carbon, right? Two hydrogens and the third one as well. So this carbon, when you oxidize it in presence of acid, of course, K2Cl2O7 कर सकते हो, KMNO4 कर सकते हो. So this carbon will oxidize to carboxylic acid. And same for this carbon. So side पे भी carboxylic acid बन जाएगा. So we can say that this is a dicarboxylic acid that's being made. No chain gets broken up. Break नहीं होना उससे. Let's look at this carbon. This is a tertiary carbon because इसके तीन carbon attached हैं इसके साथ. So I don't have two hydrogens available. So ये ऐसे का ऐसे ही रहेगा. This carbon has one hydrogen here, one hydrogen here. This will oxidize. And I'm able to get this thing. So every carbon works individually. Now, let's say I have room temperature, strong KMNO4, strong oxidizing agent. What will happen? It's a strong oxidizing agent. Now let's see. Let's talk about every carbon individually. I'm going to label the hydroxides here. 1, 2, 3, 4, 5. So these are 5 interesting sites for us. Secondly, there's a sixth one as well. Can anybody tell me और कहाँ पे oxidation हो सकती है इस compound में?
So double bond.
Double bond, yes. So that's the interesting point for us. ठीक है, अब देखते हैं करेगा क्या. I'm gonna copy the whole thing क्योंकि दोबारा draw करने में time बहुत लगेगा. Okay. So let's start one by one. So यहाँ पर this carbon is a secondary carbon, right? So the H goes away. There's another H which is obviously not being shown क्योंकि ये skeletal formula है. तो इसकी वजह से यहाँ पे double bond बन जाएगी. This carbon over here, it is attached to OH, one other carbon, and 2 more hydrogens. So it's a primary alcohol. तो यहाँ पर COOH बनेगा. तो मतलब अभी COOH बन गया. I could choose to first remove OH and then do all of that, but बनना तो COOH है ना. Same thing will happen here. This carbon is primary carbon. So यहाँ पे भी COOH बन जाएगा. This carbon is a secondary carbon. So यहाँ पर H remove होगा and I will get ketone. क्योंकि यहाँ पे 2 हाइड्रोजन थे ना, secondary carbon है. एक OH के साथ बॉन्ड थी और एक हाइड्रोजन के साथ बॉन्ड थी. So I get that. The fifth one is again secondary carbon. So the hydrogen gets removed and I get ketone. And now the double bond. Double bond, because it's a cold temperature KMNO4, so double bond goes away, but the single bond stays. So यहाँ पे OH और यहाँ पे OH. Is everybody clear what happened with all 6 of these sites? Now let's do the same reaction, but this time I'm using hot KMNO4. Of course, oxidize तो उसने करना ही करना है. So हाइड्रोजन्स के साथ, हाइड्रोक्साइड्स के साथ, या जो हमारे पास ये हाइड्रोक्साइड तो नहीं है सच, this is hydroxy group. So this will obviously oxidize and yeah. So this will oxidize, but यहाँ पर ये होगा. So यहाँ पे कीटोन बने, ये डबल बॉन्ड थी, ये CH3 था. All of that will stay, मतलब वो बाकी सारी ऐसी करेंगी. बस फर्क ये कि ये डबल बॉन्ड टूटेगी. And now once this bond is broken, you're going to end up with the double bond is gone and now they will oxidize. अब ये carbon सेकेंडरी कार्बन था, तो यहाँ पर अब ये टूट गया ना डबल बॉन्ड, तो अब ये ऑक्सीडाइज होगा और COOH में कन्वर्ट होगा। लेकिन ये कार्बन था टर्शियरी कार्बन, तो ये ऑक्सीडाइज होगा एंड विल फॉर्म कीटोन, एंड दैट इज हाउ you can draw it. You can draw it if you want. You can obviously remove it, और आप इसको ऐसे बॉन्ड भी बना सकते हो कि अच्छा नहीं इस तरह मैंने नहीं बनाना, दिस इज गोइंग टू बी लाइक दिस। आपकी मर्जी है, आप कर सकते हो। मतलब दिस थिंग ऑन दिस शोल्डर इज द सेम एज द अदर वन दैट आई जस्ट ड्रॉ। ठीक है, यू कैन ड्रॉ इट, क्योंकि इसमें भी एक 1 2 3 4 कार्बन है और इसमें भी 1 2 okay, I missed a carbon here.
Sir,
Khair, you get the idea.
So
Yeah.
in the previous case, you used cold KMNO4.
Yeah, in this one I used cold KMNO4, and in this one I will use a hot KMNO4. तो उसकी वजह से ये
सर जब cold
carbon
वाला
use किया था।
cold use किया था तो हमारे double bond पे diol बना।
Yes. ठीक है, so ये हमारे पास reaction इस तरह से proceed होगा और बाकी सारा वहीं के वहीं। So do you understand that the key to solving all of these questions is to identify your site, the important point, और फिर उसको आप individually one by one target करते जाते हो। ठीक है, all right, so that's oxidation. I hope it's clear to everybody.